Hello, my name is Ryan McCarg, and I'm a product manager on the Amazon Chime SDK team. Today, I'll be talking to you about Amazon Chime SDK messaging, including features and common use cases. Then I'll be diving deeper on content moderation and other features useful in large chat channels. This is a commonly requested feature for customers across many segments, especially those building large chat channels for live events, like concerts or keynote speeches for remote conferences. Live event organizers need to communicate in large streaming events like webinars or lectures over multiple modalities, including video and chat. But existing chat solutions can often not scale to support tens of thousands of participants. Amazon Chime SDK messaging is secure, persistent, and can scale up to 100,000 members in a single chat channel. In this webinar, you will learn how to use Amazon Chime SDK to create a chat application that can be used alongside a live stream broadcast, such as a live stream product demonstration with commonly requested features for this use case. Features covered will include moderator controls, automated moderation, message effects, and sentiment analysis. In this session, I will set context by giving a quick overview of Amazon Chime offerings. Then I will introduce you to the Amazon Chime SDK, then share use cases and features for messaging. From there, I will explain how to build a basic chat application, and then add profanity filtering, redaction of sensitive information, reactions, and sentiment analysis. Finally, I have some next steps with resources to help you get started with Amazon Chime SDK messaging. Starting with Amazon Chime offerings, in 2017, the Amazon Chime Meetings application was launched, used by thousands of customers around the world and by Amazon internally. Since then, Amazon Chime has extended the communication capabilities we offer to customers. In March 2019, we launched Voice Connector, allowing you to place inexpensive, secure telephone calls to over 100 countries from your on-premises phone system, using your internet connection or AWS Direct Connect. November 2019, we launched the Amazon Chime SDK, which is the focus of this session. The Amazon Chime SDK is broken down into three main capabilities. Media services enable developers to add audio, video, and screen sharing to their own applications. Phone integration enables inbound and outbound dialing with AWS Lambda integration to control the behavior of phone requests. Messaging, the primary focus of today's session, is highly scalable, persistent messaging that enables AI, ML enhanced workloads. Each of these capabilities can be used separately or together to build communication capabilities into your applications. Across media services, phone integration, and messaging, the aim is to help builders build faster by abstracting away complexity and accelerating development with features like UI components. To simplify their operations by providing security and compliance, utilizing the AWS Global Network, and providing scalability and performance. We also aim to allow developers to extend their applications by adding AI ML capabilities natively or through integration with other AWS services. Features like AWS Event Bridge and Amazon Kinesis integration can also be used to trigger workflows with events. Because the Amazon Chime SDK is used to seamlessly integrate communication capabilities into customer applications, you may be one of millions of people using the Amazon Chime SDK without even knowing it. Customers in health and fitness, education, focus groups, and unified communications have all added audio, video, screen sharing, phone, and messaging features to their application. For example, Slack uses Amazon Chime SDK to power audio and video for their native calling functionality. MindBody provides remote fitness classes using the Amazon Chime SDK, and Cerner provides a telehealth solution. Now that you have a better understanding of the Amazon Chime SDK, let's dive a bit deeper on the messaging features of the SDK. Starting with why you should choose Amazon Chime SDK messaging. Well, we hear from customers that they want to build chat features into their applications, but don't want to just build another application with standard chat features. They want to do more, build a differentiated experience that leverages the best of what AWS has to offer, and that they are in full control of. They don't want to have to worry about the ability to scale, expensive pricing structures with overages, or whether they will be able to meet their compliance needs. Amazon Chime SDK messaging delivers on this need, taking care of the challenging parts of building chat, offering straightforward pricing while enabling rapid development of differentiated experiences, leveraging the AWS global network and integration with other AWS services. So what are some of the common use cases for Amazon Chime SDK messaging? In healthcare applications today tend to have basic chat features, but our customers know that messaging in healthcare can be so much more, creating new experiences for chat that elevates the experience for patients and providers, powering workflows with AI and ML that will remain relevant as the world returns to normal. Amazon Chime SDK messaging in healthcare is not just for basic chat during telehealth visits, but powers long-term connections between patients and providers, between hospital staff, insurance providers, and health coaches. In distance education, students are returning to schools around the world, but the need to keep educators and students connected will remain. Amazon Chime SDK messaging keeps educators in K through 12, higher education, and in the corporate world connected, enabling one-to-one or large-scale messaging for chat or creation of collaboration tools like document sharing, whiteboarding, or document editing. Developers have the ability to create the exact experience they require with fine-grained control over what users are able to do and what content is shared. In gaming customers want chat in their games to add a social element. Ensuring content adheres to community guidelines is critical, however, so moderation capabilities at scale are a must. In sales and service, customers in e-commerce, brick-and-mortar stores, service applications, on-demand applications, and marketplaces all have a need for persistent messaging. Messaging for these customers typically connects servicemen and women and sales representatives with customers. This can be through the course of a transaction or building a relationship over months and years, such as with personal shoppers, financial advisors, and real estate agents. In e-commerce, this could be a sales representative guiding a single buyer or a group of buyers through a shopping experience on a website. For service appointments or deliveries, drivers need to connect with customers to keep them updated on the status of their order or answer questions. In each of these use cases, it is important that these conversations be connected to other customer touchpoints. Customer support needs to be able to confirm when customers are in contact with the mobile workflows, how long it took them to respond to customer inquiries, and verify what was said to resolve disputes. In the context of sales, messages sent between sales representatives and customers should benefit from context gleaned from other properties. Imagine a salesperson in a high-end retail store reaching out to a regular customer to let them know a handbag they are interested in is available. During this conversation, they have automated recommendations through Amazon Personalize that are based not just on what they have discussed previously in chat, but actions taken by the user on the website or past purchases. In events and entertainment, customers need secure, reliable messaging that scales, including common chat functionality like emojis, reactions, and moderation that allows them to enforce content standards. In events, messaging needs to cover a wide variety of use cases, from one-to-one conversations between participants for networking, group conversations such as those that take place around virtual product booths, up to chat displayed alongside keynotes with tens of thousands of attendees. Amazon Chime SDK messaging covers all of these use cases and enables advanced messaging features like translation to make it easier for users to communicate effectively. For entertainment customers, recommending content to friends and family for them to watch separately is no longer enough. Users want to experience live music, TV shows, and movies in real time, even when they aren't in the same room. This desire is met by customers connecting users via chat, available across devices, so that they can share the enjoyment of live concert together or react to content and movies as they watch them. In real-time collaboration is an area where we have seen customers really appreciate the flexibility of Amazon Chime messaging. There are more obvious use cases where customers want to add persistent chat alongside audio, video, screen sharing, and phone capabilities provided by the Amazon Chime SDK. These customers choose Amazon Chime SDK messaging because they want to add more to their chat experience. They want chat to be persistent so that it is available inside and outside the context of the meeting, and they want advanced features like translation and data loss prevention. Amazon Chime SDK messaging makes this all possible, but customers are also using messaging for more than just chat. Customers have found that Amazon Chime SDK messaging can be used for high-frequency, low-latency messaging to keep the state of clients synchronized for features like live polls, quizzes, updates to files, and even the creation of persistent whiteboards and real-time editing of files. So how does Amazon Chime SDK messaging enable all of these use cases? By following the same product goals seen across the Amazon Chime SDK, helping customers build faster, simplify their operations, and extend their applications. To help customers build faster, Amazon Chime SDK messaging makes it easy to integrate with almost any identity provider and can enable unauthenticated access when you want users to be able to join conversations quickly when they don't have an account. Amazon Chime SDK messaging also comes with common messaging features built in, including public and private channels, message editing and redaction, unread indicators, user roles, including administrator, moderator, and standard features. Amazon Chime SDK messaging provides control messages used to trigger events and UI effects in clients such as typing indicators, message reactions, and more. And to accelerate the creation of the front end, Amazon Chime SDK messaging also provides UI components. To simplify operations, Amazon Chime SDK messaging handles scale for you. There are unlimited simultaneous connections, so no overages, no limits on users, no limits on channels, and channels can have up to 100,000 members. To help with compliance, you have custom retention policies that delete all messages after they have met the retention period, which can be anywhere from 1 day to 15 years. You can, of course, also not turn retention on and keep messages forever, or use available APIs to delete individual channels, users, or messages whenever you need. We also enable export of chat messages through Amazon Kinesis for analysis and archival. As part of the Amazon Chime SDK, Amazon Chime SDK messaging comes with compliance built in, including HIPAA eligibility and FedRAMP moderate status. But as I mentioned, customers tell us their goal is not to recreate common messaging experiences. They want to build something unique and differentiated. By providing building blocks that take care of the heavy lifting for them and making it easy to integrate with other AWS services, customers are able to do just that, including building AI ML-enabled messaging workflows. Some examples of how messaging can be integrated with other services includes searching chat content using natural language search powered by Amazon Kendra, building conversational interfaces powered by Amazon Lex, moderating text, files, and images with Amazon Comprehend and Amazon Recognition, using Amazon Comprehend for sentiment analysis to determine customer response in chat channels created for keynote speeches, product demonstrations, or for one-to-one conversations like those between service workers and customers. They can build chat analytics with Amazon Kinesis, or can automate workflows, such as automating issue creation and resolution, including triggering meetings powered by the Amazon Chime SDK. They can create workflows for ordering prescriptions or automate contextual messages for delivery drivers, letting customers know their delivery will be arriving soon. While a lot is possible with the Amazon Chime SDK messaging, we have to start somewhere. So let's get started with a simple chat application that displays a single channel and takes just a few steps to set up. This is a flexible demo that can be used in multiple use cases, including next to broadcast video, in telehealth applications, or anywhere you want to display a single chat channel. Getting a basic chat experience up and running requires just a few steps. This includes creating an app instance, which is a high-level container for Amazon Chime SDK messaging. App instances contain app instance users and channels. Settings such as retention policies and streaming export of messaging data through Amazon Kinesis are set at the app instance level as well. Once an app instance is created, you'll also need to create a channel, then install the chat demo, configure it, and start the demo. Our CloudFormation template can be used to set this up for you. Once running, you can simply enter a username and join the channel to begin sending and receiving messages.
Once you have our demo application up and running, you'll see that users are only asked for their name to get started. Once the user has entered their name, they're brought to a chat channel where they can begin to send messages and receive messages. So while there's nothing particularly exciting on the surface of this basic chat application, it is a great place to start. With this, you now have a chat interface that can be plugged into multiple different use cases and that is connected to your AWS account. It is on this base that we'll build the rest of the features covered in this talk. On the next slide, we'll start to talk about what is happening behind the scenes.
The basic chat application introduces a simple process for granting users access to a channel. This is great for use cases where you want users to be able to access a channel quickly, even when they don't have a user account. Additionally, while this example is easy to get up and running, it starts to show some of the power of authentication in Amazon Chime SDK messaging. In this simple flow, you, as a developer, control exactly how users access a channel and can scope down access as you see fit by simply editing the IAM policy for the user role. For example, in this flow, you may want to tag the user as a guest to limit the user's access to a single channel rather than any channel in the app instance. You can take this even further and limit what actions the user can take in the channel, such as preventing them from listing the members of the channel or preventing them from sending messages, making the channel read-only. Of course, Amazon Chime SDK messaging works with almost any identity provider, so you can replace the Lambda shown here with your own IDP and eliminate guest access altogether, requiring all users to sign in. The basic chat application is a great place to start with Amazon Chime SDK messaging. If you want to take the chat experience further, we have a feature-rich chat demo available that includes user authentication, multiple channels, and UI components for features like editing messages, deleting messages, managing channels, and more. I've included a link to this demo in the next steps for this presentation. As I mentioned previously, what we hear from customers is they want to build differentiated experiences that take on challenging problems. In the next section, we will begin to layer on top features that are important for large chat channels. The first features covered will be profanity filtering and redaction of sensitive information. So what challenge are we addressing here? Well, moderation of user-generated content is a critical need for many chat use cases. Corporations need to prevent the accidental sharing of sensitive information. Entertainment and social applications need to ensure community guidelines are met. And brands need to ensure that content shared by users fits their brand. However, automated moderation is complex, requires unique skill sets, and is expensive to build, while human moderation requires significant human effort and does not scale. So how are we solving this challenge? Amazon Comprehend removes many of the challenges for implementing automated detection of profanity and sensitive information, such as personally identifiable information. While Amazon Chime SDK messaging provides features that enable integration with Amazon Comprehend to detect profanity, PII, and other undesired content. Amazon Chime SDK messaging also provides features including message editing, message redaction, removing or kicking users out of channel, and banning them so they cannot return. To implement detection of PII, or personally identifiable information, we leverage the ability to stream data from Amazon Chime SDK messaging into your AWS account using an Amazon Kinesis data stream that you manage. The content of this stream is sent through an AWS Lambda function that processes messages and utilizes Amazon Comprehend to detect PII. Once PII is detected, a Lambda function is called using a bot with the app instance admin role to edit the message, removing the sensitive content. To turn on profanity filtering, we leverage the same ability to stream messaging data from Amazon Chime SDK messaging into your AWS account using an Amazon Kinesis data stream. The content of the stream is sent through an AWS Lambda function that processes messages to detect profanity. For simplicity, the demo in GitHub includes a banned word list directly in the AWS Lambda function. This removes the power of Amazon Comprehend, but works well for many use cases. As an alternative, you can integrate with Amazon Comprehend. However, for that to work, you'll need to train Amazon Comprehend to recognize profanity. I have included links to resources to learn how to do this in the next steps. Once profanity is detected, a Lambda function is called using a bot with an app instance admin role to remove the content and at first notify the user that they will be kicked and banned if they continue. After the initial warning, the same process is used to again remove the content using the redact API, but this time the bot also removes the user and bans them from the channel. Let's see how that looks for users.
Here we have the same interface we saw with the basic chat application, but behind the scenes, we have Amazon Kinesis, AWS Lambda, and Amazon Comprehend, powering both detection of personally identifiable information, PII, and profanity. First, let's show how detection of PII works. For this, you can imagine someone that has just been speaking to the bank or their accountant, someone with whom they have a secure connection and need to share confidential information. They come here thinking they have copied and pasted something relevant, not realizing they have a clipboard full of information that shouldn't be shared. They paste it here and may not even realize after switching to another window. Luckily, our bot picked up the fact that they sent this information and will edit the message, removing the sensitive content. This is helpful in broadcast use cases, as well as more formal settings. I personally know people that have accidentally pasted this type of information and wish they hadn't. Having an automated process in place to remove it is good peace of mind. For profanity, it is less likely that someone is unintentionally pasting something without realizing it. For this use case, we can imagine a product presentation. The brand has put together a live broadcast of a new product, demonstrating all of its features. In comes a troll, posting a bunch of offensive content. The brand has complete control to handle this situation how they want. They can have zero tolerance or give warnings. In our example, the user has 2 warnings. After a third offense, they are automatically kicked and banned from the channel. Let's see how this works. So you see the message is automatically removed by the bot, and the bot sends a warning. The user posts again, and again the message is removed, and a warning sent. The third offense, the user is kicked and banned from the channel.
Moving on to reactions and sentiment analysis. Sentiment analysis of chat data has multiple use cases. In our demo, we show a basic example, but the same concept can be used for different implementations. For a large channel, analysis of chat content could be one metric to determine the overall response to a product demonstration or keynote, with the possibility that to identify individual users who were especially positive in their response. Outside of the context of a large chat room, the same type of analysis could be used in a dashboard to identify bad customer interactions, such as when a customer is responding poorly to a conversation with a delivery driver. So what challenges are we solving with reactions? In modern chat applications, users expect features like reactions that allow them to react to content in real time. In some cases, this may be a reaction to content in the channel. In other cases, it may be a chat participant reacting to content displayed elsewhere, such as a broadcast video. Adding reactions that contribute to the shared experience of chat participants requires low latency messaging that scales. This is difficult to build from scratch and even more difficult to scale. So how are we solving this challenge? Amazon Chime SDK messaging provides control messages that allow content clients to send small messages to trigger reactions that are displayed across all connected clients.
Let's talk about the implementation of reactions. Reactions highlight the use of control messages. In this example, it is a simple implementation where the user sends a message and Amazon Comprehend analyzes the sentiment. As before, this message is streamed through the Amazon Kinesis data stream and into AWS Lambda, then to Amazon Comprehend, where the sentiment is detected. When detected, a control message is sent down to the clients with the sentiment, which then triggers the display of the reaction. This is just one implementation of a reaction. Amazon Comprehend again is optional here. If you simply want to detect specific words and react to them rather than sentiment, you can include that list directly in the AWS Lambda function. This can be enhanced by adding additional types of reactions, counting the number of times a reaction is sent, etc. You can, of course, also choose to implement UI, such as buttons to trigger these reactions, or allow users to react to messages in the channel. You, as the developer, have full control over the experience of your users.
What challenge are we solving with sentiment analysis? While sentiment analysis is a useful tool for determining customer reaction to content, sentiment and bot commands, prioritizing messaging, or identifying bad customer experiences via chat. As with moderation, sentiment analysis requires unique skill sets and can be expensive to build. Following the same pattern as before, Amazon Comprehend is used to remove many of the challenges for implementing sentiment analysis, while Amazon Chime SDK messaging provides features that enable integration with Amazon Comprehend. To implement sentiment analysis, here we see the now familiar flow of Amazon Kinesis to AWS Lambda to Amazon Comprehend. Comprehend is used to determine the sentiment of each message, and that sentiment is sent back to the channel by the Lambda function. So here we can see what that looks like for users.
Now when we open the demo, you'll notice there's a new element on the screen for measuring sentiment. You'll also notice that when you send a positive message, that sentiment is picked up and positive emojis fly over the screen. As you continue to write positive messages, you'll notice the positive sentiment score adjusting to the new input. This process first accounts for the increase in messages, then applies the new value to the overall score. If you turn it around and start to write negative comments, you will see the same effect, but rather than positive, the emojis are negative and the negative sentiment score increases. If you enter anything neutral, you will see both the positive and the negative scores drop because we aren't displaying neutral sentiment in the UI. Of course, it works if someone else is sending messages as well. While the sentiment score as seen here is not likely to be used in this way live in a channel, it effectively shows how sentiment can be measured in real time. This type of sentiment score can be a useful tool in determining the overall sentiment of participants for a keynote or identifying participants that were particularly enthusiastic about a product demonstration.
So thank you for joining me today to learn about Amazon Chime SDK messaging. With what you have learned today, you know how to use the features of Amazon Chime SDK messaging in combination with other AWS services like Amazon Kinesis, AWS Lambda, and Amazon Comprehend to build automated moderation with detection of profanity and redaction of sensitive information. You also learned how to add reactions to chat content with sentiment analysis. And here, I have provided a few resources to help you get started with Amazon Chime SDK messaging. This includes access to the demo I shared today, so you can deploy it in your own account. You also have some general resources for the Amazon Chime SDK and Amazon Comprehend. Thank you.